So one of the most important things to know in physics is that velocity is equal to the slope of a position versus time graph, which in other words means delta x, change in position, over delta t, change in time. So I have a position versus time graph here, and the slope would basically just be the rate of change between all of these points. And I tried making them as linear as possible, so the slope in this graph is constant, which means that it's positive and it's constant. So a graph of the velocity versus time, and velocity is in meters per second. So a graph of velocity versus time would look like this, because the slope here is positive and it's always constant, so it's not changing. So here, velocity is not changing and it's positive, like we've said here. But what if the graph of position versus time looked like this? So it's starting off with a positive slope, but it's getting closer to zero gradually. So instead of a straight line, our velocity is changing now. So the slope is changing in our position versus time graph. So since it's changing, our graph of velocity versus time should change too. So here it's positive, but it's getting closer and closer to zero. So here it's like getting very close to zero. So positive, 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 getting closer to zero. So if we're going to model that, it would be positive, 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 getting closer to zero. So our velocity versus time graph would look something like that. And just like we had an equation for position versus time graphs, we also have an equation for velocity versus time graphs. And this is Vf, which is final velocity, equals v0 plus a, which is acceleration, times t. So you'll notice that this looks very similar to the position equation that we had, which is position equals initial position plus vt. So this is basically saying that our final velocity is equal to initial velocity plus acceleration times time. But this is only when acceleration is constant. So that's a very important thing to remember. So the acceleration must be the same. So here you can see that acceleration is not the same because acceleration is the slope of a velocity versus time graph. So acceleration equals delta v over delta t. So when we look at the slopes here, we see that the slopes are changing. It's almost zero, then it's going down, so it's negative. So acceleration is not constant here. So this equation is only used when acceleration is constant. Now you'll also see that velocity is the slope of a position versus time graph, while acceleration is the slope of a velocity versus time graph. But what's the slope of acceleration versus time? Well, that's something called jerk. So jerk is the slope of acceleration versus time. But that's not tested on the AP exam, so you don't have to worry about it for now.